Hello, in this video we'll be looking at composite functions, and this is for learning intention 39. Now if you were good and you did your holiday homework, you will have already done all of question 1 and question 5. So if you haven't, get on to it. No, hang on, that was chapter 1. Sorry, no. So I've got question 1 all and question 5 down. I recommend having a crack at question 2 as well, and have a go at one of 6 through to 10. Have a go at just one of these, or have a go at a few until you get what's going on. It's about domains and ranges, and read carefully, and you should be right doing those. But I've got 2 examples here, and I've just taken these directly from the book. Example 1, example 2. So we'll remind ourselves what composite functions are all about. So we've been given an f of x and a g of x, and this question here wants us to find f of g of x and g of f of x. So we're finding f of g of x and g of f of x. And it's going to ask you about things regarding whether it exists or not. So you're going to have to look at domains there to figure that out. But I'll remind you what a composite function is by evaluating these. So let's do f of g of x. So the way we do this is we take the g of x and we replace it with x squared. So we're actually finding f of x squared here. Okay, so we replace every instance of x in f of x with x squared. So we get x squared plus 1, x squared plus 3. And if you like, we can expand it out. Let's expand it out to see what it will look like. So that gives us x to the power of 4 plus 4x squared plus 3. There we are. So that's f of x squared there, or f of g of x. Another way they like to write it is f composed with g, or f of g of x. This is another way to write it, or FOG for slang. Let's find g of f of x. So this time we need to sub f of x into here. So let's do that. Let's sub f of x into there. So we get x plus 1, x plus 3. Alright, now we need to put this into g of x. So we're going to square all of that. Alright, that looks pretty interesting. And you'd probably leave it like that. You could expand it if you liked, but it would get very ugly very quickly. Let's do a bit of expansion. X squared plus 4x plus 3 all squared. And if you want to expand that, it will just get very ugly, but that's a nice final answer there. Alright, well that's all well and good. We're familiar with that. What about this here? Show that f of x equals 2 on x satisfies the equation here. How do we do that? How do we check if something satisfies an equation? Well, this is called a functional equation because it has functions in it. It's an equation, has an equal sign, and it has functions in it. So the way you check any equation to see if it's true or if something satisfies it is if you check the left-hand side. So you work out the left-hand side, and you check the right-hand side, and you check if they're the same. Much like a balance. The equal sign is a balance here, and we want to check if whatever's on the left is the same as whatever's on the right. And if that's the case, then this satisfies the equation here. So let's do the left-hand side. So we have f of x, well that's going to be 2 on x, plus f of y, which is going to be 2 over y, over f of xy, which is going to be 2 on xy. Okay. Now we're going to have to clear some space here because we're going to have to do some serious fraction manipulation. Serious work here. Alright, let's make these denominators the same. So I'm going to multiply the top and bottom here by y, and I'm going to multiply the top and bottom here by x, and we're going to get 2 on xy. Now, if you know what's going on here, if you're really clever with your fractions, you'll notice that these can actually all cancel, but let's keep going. So let's add these together. You get 2y plus 2x on xy over 2 on xy. Well, if we use that rule where you multiply the top and bottom and you multiply the middle ones, let's use that rule because we're familiar with that. And you get xy, 2y plus 2x over 2xy. Well, those cancel. And then we get, here, we get 2y plus 2x on 2x, and we can take out 2y plus x. Oh, whoops, that 2x doesn't need to be there. We cancelled that. Apologies. Over 2, cancel those, and we get x plus y. The right hand side is x plus y. It checks out. So we say therefore the left hand side equals the right hand side. And f of x satisfies that equation. Have a look at how to deal with the domain and range. Read that section because it's just kind of memorizing facts about composite functions to help you with later questions. And if you have been, thanks for watching.